ATS EVS533 students, and welcome to Lecture 4D in our fourth module of the course. And today we're going to be continuing to talk about that kind of almost fantasy of a solution to climate change, and that is geoengineering, trying to deliberately make changes to our environment to offset the effects of global warming, or exactly how you want to define it based on the last lecture is fine. And today we're specifically going to be talking about carbon cycle engineering. Last time we were focusing, well, first we did mitigation and adaptation strategies, but then after that we were talking about the first of the geoengineering strategies, namely solar radiation management. If you might remember, that was about finding a way to reduce the amount of solar radiation that is absorbed at the surface of the Earth. And there were a lot of strategies here that seem like they would work. I mean, we could talk about adding sulfates to the stratosphere, where they would be increasing the albedo of the Earth atmosphere system, keeping some solar radiation from ever even reaching the surface of the Earth. That would work. It would be a continuous effort of adding more and more of those sulfates to the atmosphere. If we ever stopped, it'd be a big problem, but it would work. It would work. We could talk about ways to make clouds more reflective by enhancing the so-called indirect aerosol effect that we learned about back in the second module of the course, where you could add things like salt aerosols and so on to the atmosphere, which increases the number of cloud condensation nuclei, particularly out over the oceans, and you end up with more of the small water droplets and fewer of the big water droplets, and those clouds are more reflective and so on, and that would be another way to manage the amount of solar radiation that makes it to the surface of the Earth. We could also take things that are manufactured or built infrastructure of the Earth, like roads and rooftops and so on, and just make them more reflective. That would also be a way, to have more of the solar radiation reflecting off, particularly big expanses of pavement or tar. They usually talk about this in terms of things like either parking lots, or like the rooftops of factories and other large big box stores and so on, or like roads, where, we have enormous amounts of the surface of the Earth covered with pavement. All those are strategies that would certainly, the physics are good. We should be able to make those things work. For that matter, we could just keep radiation from ever getting to the Earth atmosphere system in the first place by building some kind of sun shield. Now, for various reasons about how I structured this module, of course, we're actually not going to talk about the sun shield idea until the last lecture. Lecture 4E will be the last one that has new content. But that also has problems, okay? Again, it would work if we could build such a thing, keeping some of the solar radiation from ever getting to the Earth atmosphere system in the first place, but that's a whole complicated story that we're not going to get into right now. So we have these whole solar radiation management strategies that, the physics are fine, they would work. How about another way of doing geoengineering as a way of getting around the problems of global warming and climate change, and that would be carbon cycle engineering. This is an attempt to modify the carbon cycle in such a way so that we accelerate the transport of carbon dioxide from the atmosphere into other reservoirs. The verbiage I use here from a different textbook is that the carbon dioxide is being more rapidly removed from the atmosphere. Okay, whichever verbiage you like, that's fine. But we're talking about actually getting carbon dioxide out of the atmosphere. And this is a good idea, because remember, the atmosphere is a reservoir of carbon, to use the parlance of the, or the jargon or whatever you want to say, of the world of the carbon cycle. And the lifetime of carbon dioxide in the atmosphere is pretty large. It's on the order of centuries. Maybe even longer. That tends to be why we discuss these kind of carbon dioxide perturbations in the atmosphere as being irreversible. And so the idea is, well, maybe we can engineer a way to get that carbon dioxide out of the atmosphere faster than just letting nature run its course. Remember, nature will run its course. The natural mechanisms of transporting carbon out of the atmosphere and into the surface layer of the ocean, the land biosphere, even into the lithosphere in the form of, chemical weathering and so on. It can happen. We can make that happen faster, though. And there's a number of ways we can do it. The most obvious one that appeals to environmental science majors and so on is just planting trees. As trees grow, they remove carbon dioxide from the atmosphere and sequester it in the wood. For that matter, all plants do that, but keep in mind, most plants, there's sort of an annual cycle to it. Over the course of the year, the corn grows, it extracts carbon dioxide from the atmosphere, but then when the corn plant dies, bacteria and fungus and things like that in the soil break the corn husks and the corn stalks down and release the carbon dioxide back into the atmosphere. The actual kernels of corn get turned into food and we consume them and respire the carbon dioxide out. There's an annual cycle. In the course of a 12-month cycle, there's no net change to the carbon cycle for corn, alfalfa, soybeans, whatever. For that matter, any of the plants that are in your garden or anything like that. But trees are different. It is true that on the scale of like centuries, there's no net change to the carbon cycle by adding trees. But we don't have the luxury of thinking in terms of centuries right now. The truth of the matter is we can get carbon out of the atmosphere on the scale of decades anyway by planting trees and having them extract that carbon and store it in the form of wood. And, well, this kind of works, but I guess I don't know in advance how many trees this is going to take. I mean, we have a whole industrial infrastructure for moving carbon around in the terms of petroleum products. Trains a mile long bringing coal to a coal-fired power plant, and supertankers bringing petroleum from the Middle East into Port Sulphur, Louisiana. How many trees is it going to take? How many trees would you actually have to plant if you wanted to meaningfully fight global warming? Well, the answer gets to be a little bit sensitive to your assumptions. And so the more I searched in different books or online, the more I found that there's a variety of answers here. They all end up pointing to the same solution, don't get me wrong, but for the actual numbers, I've used this particular website you're welcome to go to. I think it was for North Carolina State University, but whatever. The truth of the matter is it depends on a lot of factors. How long the tree, how fast the tree grows, how much carbon it stores each year that it grows, how long the tree lives, etc. It turns out over the life cycle of a tree, averaged over its life, trees actually don't sequester as much carbon as you might think. In fact, a typical mature tree only sequesters about 13 pounds of carbon per year, according to that website at North Carolina State. It doesn't mean that they only are picking up 13 pounds of carbon. It's that a lot of that carbon is stored in things like leaves that are going to fall off and decompose, or sticks that are going to fall off and decompose. For long-term storage, like in the trunk of the tree, only about 13 pounds of carbon. I mean, keep in mind, not everything in the tree's trunk is carbon. I mean, there's water and minerals and stuff like that. So there's not really a huge amount of carbon per tree. A ton, let's see, is 2,000 pounds. So if you divide 2,000 pounds by 13 pounds per tree, you end up needing 170 trees per ton of carbon. Okay, well, if you use 2010 figures, at that time, mankind's anthropogenic emissions of carbon dioxide into the atmosphere were in the vicinity of 9 gigatons, 9 billion tons. So if you do the math here, just to absorb the carbon dioxide of a typical year, just to absorb this year's carbon dioxide, you would need to plant, 1.5 trillion trees. That's a lot of trees. Just to compensate this year's carbon dioxide emissions from anthropogenic sources. Is that possible? Can you plant that many trees? Well, at a rate of about 100 trees per acre, which is, an acre is pretty big, 100 trees per acre. Well, in the long run, that's probably about how many trees per area. I'm sure there'll be saplings in between and stuff, but in terms of like growing mature trees, 100 trees per acre is a good average. At a rate of 100 trees per acre, this requires, well, you'd have to just divide that by 100 to get the number of acres, and if you're not familiar off the top of your head how big an acre is, you'll be forgiven for that. Works out to about 62,000 square miles. Hope you're getting the idea that that's big. That would be an awfully large area. Just to give you a sense as to how big it is, the state of Nebraska is 77,000 square miles. So we're talking quite a bit larger there. I mean, we're talking a whole order of magnitude, I'm sorry, not a whole order of magnitude, 3 orders of magnitude bigger than that. An area 3 orders of magnitude bigger than the state of Nebraska would have to be reforested every year to completely offset that year's carbon dioxide emissions. Obviously, that's not possible. I mean, then we're going to do that. Not only would we not have that much area on the surface of the Earth now, what are we going to do next year when we have to do it? Feel free to disagree with any of these numbers or any of these assumptions on here. Feel free to choose a different variety of trees that would sequester 10 times more carbon than that. Feel free, I don't know, bamboo or something. I don't know, something that grows really fast and sequesters carbon really well. Feel free to plant trees that you can get more of them per acre. You're not going to fix this problem, right? I mean, different websites will come up with slightly different numbers as to how much we're talking about, but the truth of the matter is we are just putting the carbon dioxide in too fast, okay? We cannot keep up with this with regard to planting trees. But this is, so this is the fundamental problem here. We can disagree and come up with slightly different assumptions and so on. It doesn't change the net result that it isn't really possible to completely address the issues associated with climate change just by planting trees, okay? You cannot plant your way out of the problem. We cannot plant enough trees to take care of current emissions, much less past emissions, much less the emissions of the future. It just does. The math is cruel. We're not immune to math, and the math in this case is cruel. But that doesn't mean that planting trees is a bad idea or doesn't help the situation. Quite to the contrary, it means that we got to do it. It just means that we can't make it our only solution. I mean, it turns out reforestation might be enough to do some useful things, especially if we are judicious about environmental restoration and judicious about the trees that we encourage to grow and so on. I mean, while we cannot possibly plant enough trees to completely solve the climate change problem, the truth is that this reforestation strategy can delay the time in which we would reach some target temperature. And remember, if we're defining a target that, we're going to only let the climate get so much warmer, well, the clock is running. We only have so many gigatons of carbon we can add to the atmosphere before we hit that target. You know what? Reforestation buys us some time. Let's say significant research efforts on management of forests and so on. We could get enough efficient forests in place that a significant reforestation effort could delay the rate at which a time in which we got to some threshold, let's say 2 degrees Celsius. Let's say we bought ourselves an extra decade. Okay, instead of reaching that threshold by 2070, we reach that threshold by 2080. You know what? That's 10 more years. That is 10 more years, not so much 10 more years that you can drive your SUV and stuff like that, but it's 10 more years in which new technologies could develop or become more cost effective or whatever for mitigating and adapting and so on to climate change. That's nothing to sneeze at, okay? It might not be enough to solve the problem, but delaying it and giving us time to find an answer is not such a bad thing. And there's no doubt about it, healthy, mature forests also do accelerate the rate at which we could eventually recover from climate change and get it back towards pre-industrial conditions. When the day comes that we are not emitting fossil fuels back into the atmosphere, whenever that might be, having a healthy ecosystem to be removing carbon dioxide from the atmosphere and putting it back into the land biosphere is intrinsically a good idea. Okay, so even though we can't really solve our problems, we can certainly work at the margins of the problems here. And that is not necessarily a bad thing. Plus, of course, let's not kid ourselves, planting trees is an intrinsically good thing. It's the right thing for all kinds of environmental reasons that aren't explicitly about climate change. About things like soil management and erosion management and habitat for birds and things like that, and management of, shelter breaks for wind management on farms and things like that. There's lots of reasons why, obviously, forests are intrinsically a good thing, and we should be working for them, even if it isn't necessarily solving our climate change problem. Okay. Alright. Before we move forward to other ideas about how we could geoengineer our way out of our global change problem, let's answer 2 quick questions here. Question 1. In our estimation of the number of trees that you would have had to plant in order to offset anthropogenic emissions, which of the following limited the effectiveness of a solution like this? Was it A, each year a single tree actually only sequesters a few pounds of carbon? Was it B, you can only plant about a dozen trees per acre? Or C, trees make no net change to the carbon cycle over the course of a year? They all had kind of a ring of truth to it. Which one was the one, though, that was actually what was limiting the effectiveness of that strategy of planting trees? Make a choice from those 3 options and get a little feedback before you move on to question 2.